Picture this: a capsule returns to Earth from a daring mission, a journey that spanned millions of miles and years of meticulous planning. Inside, a treasure lies dormant, pristine samples from a distant asteroid, untouched by the ravages of time and space. This is not science fiction. This is the calm ingenuity and boundless curiosity. It's the incredible story of NASA's OSIRIS-REx mission and the asteroid Bennu, a mission that aimed to unlock the secrets of our cosmic past. Bennu, a relic from the early solar system, holds clues to the origins of life itself, a time capsule from the dawn of our solar neighborhood. Like a cosmic time capsule, it has preserved ancient molecules for billions of years, offering a glimpse into the building blocks of life. When scientists opened the OSIRIS-REx capsule, they uncovered a revelation that could rewrite our understanding of life in the universe. A discovery that could change everything. The discovery, organic molecules, the building blocks of life as we know it, were found within the samples from Bennu, molecules that could tell us how life began. This finding sends ripples through the scientific community and beyond, sparking excitement and wonder about our place in the cosmos, igniting imaginations everywhere. The secrets held within these tiny grains of asteroid dust have the potential to unlock some of the universe's biggest mysteries that have puzzled humanity for centuries. It's a story that stretches back billions of years to the very dawn of our solar system, a story that continues to unfold with each new discovery. Bennu's secrets are not just about the past, they are keys to understanding our future in the cosmos. The journey began in 2016 when NASA launched OSIRIS-REx on a mission to Bennu. This ambitious endeavor aimed to rendezvous with the asteroid, study its surface, and return a sample to Earth. It was a journey fraught with challenges, requiring incredible precision and ingenuity. After traveling for 2 years and over 1 billion miles, OSIRIS-REx reached Bennu in 2018. The spacecraft spent almost 2 years orbiting the asteroid, mapping its surface and analyzing its composition. Scientists chose Bennu for this mission because of its age and composition. Bennu is a carbonaceous asteroid, meaning it's rich in carbon, a key ingredient for life. It's also incredibly old, dating back to the earliest days of our solar system. This makes Bennu a prime candidate for holding clues about the conditions that led to life's emergence. In October 2020, OSIRIS-REx successfully collected a sample from Bennu's surface using its touch-and-go sample acquisition mechanism, or TAGSAM. The spacecraft then began its journey back to Earth, carrying precious material that could unlock secrets of our cosmic past. The sample is expected to arrive in 2023, where scientists eagerly await to analyze it and uncover the mysteries it holds.
The discovery of organic molecules in the Bennu samples is monumental. This finding has the potential to reshape our understanding of the building blocks of life. These aren't just simple molecules. They're complex structures that form the basis of proteins and DNA, the blueprints of life. The presence of such intricate molecules in an asteroid is both surprising and exciting. Finding these molecules in an asteroid billions of years old suggests that the ingredients for life were present in the early solar system. This discovery provides a glimpse into the ancient past, revealing that the potential for life has been around for a very long time. This discovery adds weight to the theory that life on Earth might have originated from extraterrestrial sources. It opens up new avenues for research and exploration, challenging our current understanding of life's origins. Imagine this. Billions of years ago, asteroids like Bennu bombarded the early Earth, delivering these vital organic molecules. These impacts could have been a crucial factor in the development of life on our planet. These molecules then served as the starting point for life to emerge in Earth's primordial soup. The harsh and dynamic conditions of early Earth provided the perfect environment for these molecules to interact and evolve. It's a paradigm shift in our understanding of life's origins. This discovery encourages scientists to rethink the processes that led to the emergence of life on Earth. It suggests that the seeds of life might be scattered throughout the cosmos, carried on the backs of celestial wanderers like Bennu. This idea expands our perspective, hinting that life could potentially exist elsewhere in the universe, waiting to be discovered. The detailed chemical analysis of Bennu samples has revealed a variety of organic compounds, including amino acids, which are the building blocks of proteins. This discovery is crucial because it shows that the basic ingredients for life can form in space and be delivered to planets. Simulations suggest that these organic molecules could form in the cold, dense regions of space, where they are protected from harsh radiation. As asteroids travel through the solar system, they can carry these molecules to different planets, potentially seeding life. The implications of this discovery are profound. It not only supports the idea that life on Earth may have extraterrestrial origins, but also suggests that the universe could be teeming with life, waiting to be discovered. This finding is a significant step forward in our quest to understand the origins of life and our place in the cosmos.
The idea that asteroids could deliver life's building blocks to Earth is not new, but the Bennu findings provide the most compelling evidence yet. Imagine the early solar system as a chaotic place, with asteroids and comets hurtling through space, colliding and breaking apart. These celestial bodies acted like cosmic delivery services, transporting essential materials across vast distances. Some of these materials, like water and organic molecules, were crucial for the emergence of life. As these asteroids journeyed through space, they eventually collided with Earth, delivering these vital ingredients. The Earth, with its favorable conditions, became a fertile ground for these ingredients to come together and spark life. So, while life itself may not have originated on Bennu, this ancient asteroid could hold the key to understanding how life's ingredients were delivered to our planet. It's a humbling thought that our very existence could be linked to these celestial wanderers, traveling through the cosmos to bring life to Earth.
Section 5. The Cosmic Cradle, How Life Arose on Earth. Now, let's journey back to the dawn of our planet, a time before continents or oceans, when Earth was a seething volcanic inferno. Picture a world dominated by fiery eruptions and molten rock, where the air was thick with volcanic gases, a true crucible of creation. Envision a primordial soup, brimming with organic molecules, delivered by celestial messengers like asteroids Bennu. These space rocks carried the essential ingredients, amino acids and other organic compounds, that would become the very essence of life. This primordial soup, electrified by the fury of lightning and bathed in ultraviolet light from the sun, became a cauldron of potential. The energy from these natural forces ignited chemical reactions, forging more complex molecules in a cosmic dance of creation. Over eons, these organic molecules began to interact, forming intricate structures. In laboratory simulations, scientists have recreated these ancient conditions, witnessing how simple molecules can evolve into more complex forms, echoing the birth of life. Eventually, these structures achieved a miraculous feat. They became self-replicating, giving rise to the first single-celled organisms. These tiny pioneers were the harbingers of life on Earth, capable of reproduction and evolution. This marked the genesis of life on our planet. From these humble beginnings, life began to diversify and adapt, weaving the rich tapestry of organisms we witness today. The odyssey from simple organic molecules to complex life was long and fraught with challenges. It involved countless trials and errors, with many forms of life emerging and vanishing over billions of years. Yet, the discovery of these molecules in Bennu offers a profound revelation. The ingredients for life were present in the early solar system, potentially setting the stage for life to arise on Earth and perhaps beyond. This finding ignites the hope that life could exist elsewhere, waiting to be discovered in the vast, uncharted realms of space.
Section 6. Bennu's message echoes of a distant past. Bennu is like an ancient tome, its pages whispering secrets from the dawn of the solar system. These secrets are inscribed in the language of molecules, and scientists are only beginning to unravel their mysteries. The discovery of organic molecules is merely the prologue in this enigmatic saga. Further analysis of the Bennu samples will unveil deeper layers of the asteroid's composition and history. It's akin to assembling a cosmic puzzle, with each revelation drawing us nearer to comprehending the grand tapestry of our solar system's birth and the origins of life itself. Each fragment of data from Bennu is a murmur from the ancient past, narrating a tale of a time when our solar system was young and the seeds of life were being sown among the stars.
Section 7. Are we alone? Implications for life beyond Earth. The discovery of organic molecules in Bennu has profound implications for the search for life beyond Earth. If the building blocks of life were present in the early solar system, it stands to reason that they might be common throughout the universe. This means that the potential for life to exist on other planets and moons is greater than we previously thought. Perhaps, on some distant world orbiting another star, similar processes are underway, with organic molecules delivered by asteroids seeding the potential for life. The universe is vast and full of possibilities. The Bennu findings give us hope that we are not alone, that somewhere out there other life forms may have emerged from the same cosmic ingredients. The concept of habitable zones, regions around stars where conditions might be just right for life, expands our search parameters. With advanced telescopes and space missions, we are now able to detect exoplanets and analyze their atmospheres for signs of life. Even microbial life, if found, would revolutionize our understanding of biology and the potential for life in the universe. The search for intelligent civilizations continues, with efforts to detect signals or other signs of advanced life forms. As we explore further, each discovery brings us closer to answering the age-old question: are we alone in the universe?
Section 8, the quest continues, our future in the cosmos. The OSIRIS-REx mission and the discovery of organic molecules in Bennu represent a pivotal moment in our exploration of the cosmos. They remind us that the universe is full of wonders waiting to be discovered. This discovery is not the end of the story, it's just the beginning. As we continue to explore our solar system and beyond, we must keep our minds open to the possibility of finding life, even in its simplest forms. The quest to understand our place in the universe is one of humanity's greatest endeavors. So I leave you with this question: what other secrets does the universe hold, and will we be bold enough to uncover them? Our future in the cosmos is bright, filled with endless possibilities and the promise of new horizons. Let's embrace the adventure and reach for the stars.